Hello everyone, this is Sanjay from CSIT branch. Today my AAT Tech Talk topic of cloud application development is COMPACE, Compliance Aware Cloud Application Engineering using blockchain. So we are going to know now about what is the abstract of this paper. The COVID-19 pandemic has highlighted our dependence on online services from government, e-commerce, retail and entertainment, often hosted over external cloud computing infrastructures. The users of these services interact with a web interface rather than the large distributed service provisioning chain that can involve in interlinked group of providers. The data and identity of users are often provided to service provider who may share it or have automatic sharing agreement with backend services such as advertising and analytics. We propose the development of compliance aware use, particularly with reference to the European GDPR regulation. Key compliance operations and the perceived implementation challenges for the realization of these operations in current cloud infrastructure are outlined. Cloud application engineering, which is able to improve transparency of personal data. With the increasing demand for extremely hosted services spanning industries like government, finance, e-commerce and entertainment, many of these services rely on cloud computing infrastructure. While users typically interact with a simple web interface, the underlying services are part of larger distributed ecosystem involving a multiple third-party providers. These backend services may handle tasks such as analytics, user profiling and advertising, often without the user being fully aware of how their personal data is shared or used. As a result, users unknowingly entrust their data and identity to service providers who may share this information with several other services. To address this lack of transparency, the General Data Protection Regulation was introduced to give users greater control over their personal data. GDPR ensures that users, especially non-experts, can make informed decisions about their privacy by providing informed consent before their data is used, stored, or shared. This regulation aims to enhance users' understanding of how their personal data is handled, allowing them to make choices about its use. However, implementing GDPR poses challenges for both individuals and data controllers. Individuals or data owners must be able to easily understand complex data practices and provide clear consent. Data controllers in turn must ensure that consent is obtained in transparent, accessible manner while also managing compliance with GDPR requirements. These challenges require improvements in user education, consent mechanisms, and transparency in data handling process, all to maintain user trust and data privacy. One of the major challenges in context of data management and protection is the confusion between the terms security, privacy, and compliance. While these terms are often used interchangeably, they have distinct meanings in practical use. Security refers to protecting systems and data from harm or damage, such as preventing unauthorized access, attacks, or disruptions caused by malware, hackers, and or other malicious entities. It focuses on ensuring resilience against threats to safeguard the integrity and availability of services. Privacy, on the other hand, pertains to the protection of sensitive information related to individuals or groups. It emphasizes the it emphasizes the need to keep personal data scheduled and free from unauthorized access, particularly when the data is sensitive or private to an individual. Compliance involves adhering to specific rules, policies, to or regulations set forth by governing bodies. Its significance conforms to guidelines, standards, or laws designed to ensure that data handling practices are lawful and ethical. For instance, the General Data Protection Regulation outlines seven key principles that organization must follow, like lawfulness, fairness, transparency, purpose limitation, data minimization, accuracy, storage limitation, integrity, and confidentiality and accountability. These principles ensure that organizations responsibly manage data, balancing the need for security and privacy while following legal requirements. Commercial cloud providers such as AWS, Amazon Web Services, and Google Cloud and Microsoft Azure offer robust solutions for infrastructure provisioning and scalability, but their support for compliance adherence, particularly regarding GDPR, is often limited. While these providers focus heavily on security and limited privacy measures, their primary emphasis remains on providing elastic infrastructure such as rather than ensuring full compliance with data protection regulations. Services like function as a service such as AWS Lambda, Google Cloud Functions and Microsoft Azure Functions allows users to deploy manage applications without worrying about the complexities of underlying infrastructure, which the cloud provider handles. Similarly, AWS CloudFormation offers a configurable environment for managing cloud resources through templates, enabling users to build and test locally or in Amazon S3 with ease. Despite these advancements in infrastructure management, concerns persist around the risk of data breaches and potential loss of sensitive data when using cloud services. Organizations and individuals utilizes cloud platforms remain apprehensive about the security of personal data, especially in the context of strict regulations like GDPR. Although cloud providers continuously improve speed, scale, and quality of service, compliance with the data protection standards remains a challenge. Provide a summary of potential data breaches that can occur with cloud environments, highlighting the importance of auditing mechanisms to mitigate these risks and ensure better compliance practices. So, this is the architecture of the uh, Compass architecture for hosting services in a multi-cloud. Here we can see the applications like e-commerce, financial banking, post-delivery, airline reservation, healthcare, and governance, and also the components of cloud engineering are smart contracts, blockchain, and platform as services, serverless computing, cloud formation, function as DB servers. This is the picture of the Compass architecture. The Compass architecture is compliance-aware cloud application engineering approach addresses the challenges of ensuring compliances in cloud services by integrating a multi-layered compliance-aware service stack into traditional and cloud infrastructures. The Compass architecture, as shown in figure, operates with a distributed service ecosystem with a focus on compliance verification and checking at various stages of service delivery. The architecture is built on top of the infrastructure as service layer, which utilizes multiple cloud services providers. The IaaS layer is managed through virtualization technologies such as VMs or containers, allowing for flexible and scalable infrastructure management. What distinguishes the Compass framework is the introduction of dedicated compliance layer embedded with the traditional cloud stack. This layer ensures that all cloud services are not only delivered efficiently but also adhere to relevant regulatory frameworks such as GDPR or other data protection laws. The compliance layer continuously checks and verifies the service operations to ensure the data handling, storage, and sharing practices conform to these regulations. So, the compliance provisioning is cloud SDKs are often modern approach to hosting web applications and managing data and services, but they fall short when it comes to ensuring comprehensive compliances, especially with regulations like GDPR. Current APIs with these SDKs such as Cloud Elements, AWS Compliance Program, and Redlock provide mechanisms for secure access to user assets and personal data. However, their compliance capabilities are limited or non-existent, particularly in meeting GDPR stringent requirements for data protection and privacy. For example, Cloud Elements, if hosted on AWS, emphasizes robust security practice, including the file integrity and multi-factor authentication, yet it lacks any built-in GDPR compliance controls or enforcement mechanisms. One of the significant limitations of these APIs is their inability to offer a multi-level trust environment for compliance provisioning. Despite implementing strong security measures, these solutions fail to address critical compliance issues such as tracking data usage, ensuring data minimization, and providing a clear audit trail for operations performed on personal data. This gap leaves organizations vulnerable to non-compliance risks, as the absence of traceability makes it difficult to vary if data has been handled according to legal regulations. Conclusion is that privacy and consent are fundamental pillars of European GDPR regulation, designed to ensure transparency and fair use of personal data in cloud environment. These requirements necessitate a shift in current cloud application engineering and implementation to prevent the sharing of user data without explicit consent. In this context, Compass offers a promising solution by enabling compliance-aware cloud engineering through three key operations like compilation, provisioning, monitoring, and verification. These operations ensure that the data handling practice align with GDPR requirements by embedding compliance mechanism directly into the cloud service architecture. The Compass framework achieves this through a multi-layered service stack that integrates compliance features alongside traditional application services. By embedding compliance into the core functionality of cloud services, organization can proactively ensure that user data is processed and shared in accordance with privacy laws. However, implementing these framework usability while meeting GDPR standards, this programming operation must balance regulatory compliance with operational efficiency, ensuring that privacy and consent are respected through the data lifecycle. These are references of my project. Thank you.